Hello everyone and welcome into yet another live stream, and yeah, that's enough of rest, I suppose. Time to make another video. How are you all doing? Hi there, hi the dog that can explode. Hi the turbulence, hi the spoon that isn't live, hi there Gabriel, hi. Welcome, he's still alive. I'm fine. I'm actually doing surprisingly well. I'm running the newest video. Yeah, how is the newest video coming? How did you like it? I know that YouTube did. YouTube liked that video. YouTube liked it a lot, in fact. It is the best performing video ever. At this time, which is 14 hours in, I've never made a video which would be performing better, so YouTube liked it. It was heads. I got demolished by the Radiant joke. Yeah, I know, I'm hilarious. Question, how do you get ideas for videos? Example, negative energy. Actually, ideas aren't difficult. I would recommend, well, really often I go for walks where I just, need to clear my head. And then I would really recommend for anyone who needs any fresh ideas, just go for a walk and don't plan on doing anything interesting. Just force yourself into boredom. Because then your creative spirit kind of awakens. Then, well, your brain either has to be bored or has to think of something, in which case it ends up thinking of something. And actually, speaking of thinking of something, 2 videos which we're gonna make, looking into new things. Yeah, looking into new things is also important, otherwise you're just not gonna have any, hold on, music, right. Actually, we're gonna start working 2 new videos. I realized that, hi Delia, I realized that whilst my M drive is practically full, goodness gracious me, it's because of the video I've gone and bloody made. I realized that maybe going strictly in one direction won't be too good, so we'll be working on 2 videos with 2 completely different topics, completely different genres of math, not math, science. Actually, they won't be math videos. They will be physics and chemistry. But there will be fun physics and hopefully cool chemistry. That's the hope, at least. There we go. Alrighty then. So you both have as much you come up with ideas to entertain yourself in a nutshell. Yes. Yes, that's what I do. The next video will be out before stream 696. It better be. I should make like 7 videos in between now and then. At least. I need to pick up the pace when it comes to video making. That's why we'll be working on 2 of them instead of 1. Haha! That's my plan for the future. Instead of working on 1 video, we will be working on 2 of them. Why am I like this? Okay. What are you doing right now? Is this live video? Yeah, actually we have, that's something we have been doing for quite a while, because even the last video, we've made most of it on stream. The series of live streams, every single yellow live stream is me walking on the video. I do it a lot. An awful lot. An awful lot. Oh, back then we were working on the gravity, not gravity, on the breaking physics using, not breaking physics, the is gravity real video. That was fun. A lot is an understatement. Oh, that's if I do it every day. Well, no, hold on. Yesterday we played the finals, okay? For an hour. That's something. So math becomes difficult in the theaters. I nearly fainted in my ideas. Yeah. That's the real cinema. Cinematography. Actually, I do it often. Right here I finished with how math becomes difficult. This one was that's how you break physics. Then you break physics using math. This is then you did physics in 7 dimensions. That was a dumb one, but I still stand by it. That's what is energy, I'm pretty certain, is what I said at the end over there. And everything about electrons. I do it a lot. I should stop. To go, and my favorite video you made is negative energy. Really? Oh, that's most of the time it's addition to quantum mechanics. Turbulence, you may be the only person I've ever had. I like it. I like it. Finally, someone with a different opinion. Videos negative energy. I don't hate negative energy. I mean, it's certainly still in my top 16 videos. I should really just keep a YouTube tab on the side. I don't know why, I just keep moving it, whatever. I do have a playlist of my top 16 favorite videos. I know, and I'll be honest. This video finally, in my opinion, has beaten the addition to quantum mechanics. Finally, it's about time that we had a video which I consider better than addition to quantum mechanics. I made this video 8 months ago. It's about time. And it's good right now. Well, object animating. What are you doing watching the stream? Time to learn. My favorite one is physics in 7 dimensions. Oh, physics in 7 dimensions, solid. It's my 8th favorite one. Breaking physics using math is my 11th favorite one. But I know it should be above quantum mechanics. Hold on. I need to move it to the second screen because otherwise YouTube just breaks and gives up and refuses to. No, never mind, it's still broken. YouTube, how about instead of updating the... No, I'm just kidding, YouTube. I love you, YouTube. YouTube is my favorite online media because I love YouTube so much. YouTube, thank you so much for giving me impressions on the most recent video. Oh, if you know what, I sometimes just spend hours talking about how much I love YouTube and Google and Alphabet. It's just amazing. Negative energy is fun. Gravity isn't real. I do believe this one's better simply because this one has better animations. And the conclusion is a bit nicer. Like right here, breaking physics using math was fun certainly, but gravity isn't real. It had the gravity, you know, the 3 definitions of gravity, which is pretty nice. Big science fan, your channel was no negative energy was the video I watched from you. Well, and I'm glad I can. That's so nice. I'm glad I can make videos then. But yeah, I have 2 videos which I want to work on now. 2 of them. Is the music too loud? It seems a bit okay. 2 of them. Chemistry. So wait, so our photon's real now? Well, it depends. I mean, our video, but paid attention. It depends on how you define real. Like, are abstract concepts real, sort of thing. I'm pretty certain Vsauce also made a video of this, but Vsauce didn't include 3 definitions for gravity, so I'm just saying. 2 videos. One of them will be why advanced chemistry is easier, which I already scripted a fair bit of. Which will just be explaining, you know, different topics in chemistry, which, let's just say, really poorly explained in schools. Explaining it a bit better, with a more graphical approach and more intuitive one. And then the second video, which I think y'all might like a lot, which is the 4 forces of the universe, which will just be like a mid-deep dive into fundamental forces, where there will be just 5 chapters. So introduction, not an intro, an introduction, gravity, electromagnetism, strong force, strong force, and then weak force. Whoa, 1. I don't know. I don't know which way I'll go with the strong force or weak force because that's stuffy. There's adding a lot of hashtags in the description. I heard it helps. I haven't seen it helping in any meaningful way. It isn't really about hashtags, it's about click-through rate, and hashtags don't really do anything. Well, I could try, I guess. Making is the realist. Hi, Deloheat. Hi, Krish. Welcome. By the way, animations are on Blender, correct? If so, wow, they're really good interactive, at least from my perspective. Yes, they are in Blender. Actually, we can go and take a peek if you want. I had my PC off for the entire night for the first time in a really long time, so... would be a good one. Is 11 the last one? I do believe so. This is the thumbnail. Which is just... all of these combined. There we go. This one looks a bit... I still have no idea why, but this right here... as you can see, it's mostly pink, and then only white at the very end. When I render this... it moves back. Now it's mostly white and only pink on the very beginning. I have no idea why. I've imported all of these from different files from the previous animations, so I have no idea what kind of witchcraft I've unleashed upon this file, but it works. All that matters. Which of the four do you think is the hardest to explain practically? Depends. Intuitively, strong force, but in my opinion, it's the weak force that's toughest. That's because strong force could be easily explained by just being like, yeah, it's quarks, that's it. It's not going to make sense. Like, strong force has no solid analogies, because it's just the quarks. There isn't really anything that comes even close to the strong force, but the reason why it's a weak force, in my opinion, is because weak force is just so bizarre. It's nuclear physics. It's really weird. I don't have a strong grasp of a weak force, maybe that's why, and that's a pun, you're welcome for it. I prefer for the test tomorrow. Well, good luck on the test, Lloyd. No, it's fine, Turbulence, it's fine. Alright, so... this won't be fun. Well, for gravity, it's simple enough. I do know gravity. So gravity will be simple enough. And oh, we'll need to understand carry particles, won't we? No. Okay, so for this video, what I will need to research is to do. It's going to be festive. Electromechanics, carrier particles, strong force, and weak force. That's because I only know gravity that well. I know electricity, but I don't know electromagnetism properly enough, and strong force and weak force, it's really confusing. Cardigan is right to have to make a video release. Is it the play on... I still don't know if it was a meme or a true fact with the Dragon Ball. I've just been duped by the data. I've been misinformed. But that's the physics one. I feel like it will be a pretty sweet... and then, yeah, and then in the end, obviously, the conclusion chapter or whatever, I don't know. I'll think of something. I'll think of some grand lesson at the end, you know. Conclusion could be just us using these to build up a more complex force. For example, temperature would be a good one. Or something. Average shopping list of a physicist. Hi, the Vibu. Electromechanics hopefully won't be that difficult because as I already mentioned, I did... Can I... oh, I cannot, okay. Won't be difficult because I mentioned now I'm also working on the electromagnetism video. Oh yeah, electromagnetism video! Not electromagnetism video, electricity video. The one which I've been foreshadowing for such a long time and haven't actually gone around to finishing, so yay. Carrier particles. For the fundamental forces. Absolutely not. I am not going into the 33rd chapter. That's ridiculous. I don't think that's college physics. Newton's law of motion. Yeah, I don't think that's gonna be it. That might be too advanced. I just go for fundamental forces. I might need to go for fundamental forces. New video, although I didn't understand shit. Really? Nothing? I do believe that the Fourier explanation was actually rather slick. The pronunciation of Mandeville's... Oh, pronunciation. That's difficult, my guy. I don't know. Hi there, guy. New video is cool. Thank you. I did work on it for a long time, didn't I? Do you feel yourself getting a better grasp of each argument as every video goes by? Yes. Sandy, making videos help, simply because... The thing is, the toughest part of explaining things is that you cannot, at the very beginning, have a full grasp of what the entire explanation will look like. You just simply cannot. It's too grand. At least for me, my brain cannot handle it. Each explanation is just too big for my brain. And so because of that, I need to start with a certain topic and then build up from it, of course. And each time I do it, I get a better understanding of how to tie in each topic together, which in turn leads to me just understanding the topic better. Hi there, Shad. Hi there. That's a lot of different characters you have in your nickname there. Hi there, Sean. Which degree do you have? Well, only first degree burns, but nothing else really. Fourier transform is good, that's what I understand it. That was a simplified Fourier transform, but that's the basic gist of it. If you understood, then that's first of all impressive, and I'm also really glad. I really am glad. It is fun to put it this way. I don't know how Freeblon Brown explained Fourier transforms, because it's a policy of mine that, you know, when I'm making a video, I cannot watch any other videos on the topic to not plagiarize. So I don't know how much I've missed. I do believe Freeblon Brown's screenshot would have been a bit more elegant, but I feel like this conveys the basic gist of it pretty well. Watch the Freeblon Brown video on it. Ah, I see. You're making me curious on the stuff. Making people curious on the stuff which college makes us hate, yeah. Isomers, optical isomers, and non-superimposable mirror images of each other. Name one more term. From Visos short on YouTube. Oh, that's amazing. Oh, I hate these questions so much. P and Q are called stereoisomers, optical isomers, and non-superimposable mirror images of each other. That's so awful. I don't like... Isomers are so dumb. That's my hot take. That's because they are... It's so... They are mentioned so often, but so rarely the distinction... It's not the distinction matters. Distinction obviously matters. But they are mentioned so often, but the consequences of different types are so rarely used. Like, yeah, I know... You can have different molecules using the same atoms with the same lengths between them. But why so many names then? How do you pry? No Remco? I don't know, actually, like, if we're truly in need of Remco would be reveal themselves. Nuclear and particle physics, of course, it's nuclear and particle physics. Ha ha ha, hee 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 ha. This one we might need to go... Well, history, we don't really care about that. We might need to start with chapter 2. And then only build up to 6. You remembered it from Breaking Bad. Now you're from the website. Oh yeah, this is LibreText. This is what I used for learning for my videos. First of all, let me quickly see how we're looking. Attribution, no conventional share alike. Cool, that's great. Let's link this in the description then. We can go straight into it. I'm so sorry for the voice crack. We can go straight into it, I suppose. First link in the description will be the textbook, in case anyone wants to follow along. Accelerators coming. Alright, bye. I don't like isomers. Yeah, isomers are really weird. Mainly because it's one of these topics where it's there's a lot of names floating around, there's a lot of definitions floating around, and there aren't that many cases in which these definitions would be useful. As I mentioned, distinction, like differentiating between different molecules is extremely important. And if you mirror a molecule, it is really a different molecule. That is important. But I don't understand why there has to be so much, like, there has to be just so many words, so many definitions around this topic. I'm agree with hi Desentray. Yeah, I do like that video. I love it and I hate that video and I don't care for it, to be honest. Oh yeah, this is nuclear physics. No, particle exactly. Different, although two will find together. So yeah, we have these two. I could also work on the animations. Huh. Make it study. I mean, it's not really about studying, it's about making the video. And right here I'm gonna make the video by scripting it, right here I'm gonna make the video by making animations. You know what? Let's do a democracy. Let's do a democracy. I like it. Let's do a democracy. What shall we do? Animate atoms or research? Oh, would this have an R? Research. No. Find out forces. No, it's not good enough. Fine. Research actions. Let's go for it then. I'm not gonna call it nuclear physics because then we'll pick it. Democracy being dumb or genius depends on people. I don't remember where I got this from. Yeah, but so in this case it should be genius. Haha. Research interactions? 100%! I had a 100% vote for a second. Oh, fine. Fine. Research the interactions. That's on you. Can you make a video on magnetism and interactions of electric current? Technically this one, I will make the video on interactions of electric current. I will not make a video of magnetism. Well, maybe in the future I will make a video about magnetism because... yeah. You're good at magnetism. Consider me impressed. I don't love magnetism because it seems really hard to apply in any way. It's weird. Magnetism feels like electricity's weaker cousin. Every single unit, when it comes to magnetism, has... it basically feels like if physicists took electricity and painted it in blue, which I guess makes sense, it is electromagnetism at the end of the day. But all the units, all the electromagnetic units, I know you've seen it. Electromagnetism units. Well, give me the appropriate SI electromagnetism unit. I don't know if you've seen the units, but it's so funny. Because it looks like a lot, and it is a lot. But right here you basically have electric, and then you have the exact same thing except magnetic. Every single one of these basically, almost every, I think every single one actually, every single one of these has its own electric counterpart. And there are more electric units because people care more about electricity than magnetism. Do we have video on waves? It's in the works! Play Silly Monkey game. No, we're not playing the Silly Monkey game. We have a video to make. Okay, I don't want to be stuck in like 2 weeks. I don't want to be stuck with an unmade video just like I have been for the past 5 days. If I want to avoid the absolute train wreck that it is when I just am stuck with no video finished and streaming every single day, just me making a video, then we need to get moving. With research. Boy, it's gonna be a thrilling live stream, isn't it? But you overtime is nice. Yeah, I feel like I'm just missing the basics in this case. When it goes to magnetism, I'm just missing the basics. Which is weird considering how well I know electricity. I know a lot about electricity and borderline nothing about magnetism. Like electricity from a chemical perspective, from a physical perspective, from an engineering perspective. How does humanity know this? In inverse time scale, we're messing with sticks, and in the next second we have knowledge so big people are scared of it. Well, that's exponential growth, and that's the power of intelligence. Intelligence speeds up progress, and progress is a feedback loop. Both nuclear particle physics are accelerator particles, in most cases relativistic. In order to understand why this happens, we need to look at its plane. Accelerator nothing but maximum energy, so it doesn't really matter the mass of the particle is, the energy only depends on the momentum. Okay, basic relativistic quantum mechanics equation. I'm pretty certain this is Einstein and this is the equation which is everyone's beloved. My speaking assessment test tomorrow has significant part of my college attendance marks. I'm kind of an introvert. Oh, don't worry, Vibu. Technically, so am I. You'll be surprised. When it comes to public speaking, it's actually not really about if you're an introvert or if you're an extrovert. It's more about getting into character. You just need to get into a character of a confident person and then... there. That's how I do it. Like, I love being social, I love doing social stuff, but at the same time, I have been so isolated for such a long time that I have become a bit of an introvert. And yet still, I'm streaming every single day. Literally every single day. You need to get into character, that would be my advice at least. From which we can conclude that this, once again, our beloved, which is... I've made a whole video about this, so... Any more tips of that? That's kind of it. Just try to imagine who would you like to be on the stage. So think of how you would like people to perceive you, and then get into that character. Try to define it as well as possible and try acting like it. Why is the poll vote still up? Oh, it's because in case at any point, you know, anyone would decide that they would like to change their vote, they just can. You know, if everyone realizes that research isn't quite as fun as it seemed, then everyone can just change their vote and I can go to making animations. But glad I could help. Okay, so this is just basic relativistic quantum mechanics. Oh. Oh, I suppose this makes sense. We have atom, nucleus, nucleon, quark, and the energy is going up. That's because right here, wavelength is inversely proportional to the energy. Are you in school and college? No, I am not. Into intuition behind it. Yeah, I do believe it's just convention, if I'm not mistaken. Not that much of a magnet. It's the same thing as flow of electricity. So electricity flows from the plus to minus when it comes to engineering because of convention. There really isn't much to say there. Pretty early, yeah. 10? Goodness gracious me. Everyone thinks they're an introvert, but they are not. I mean, yeah, labels kind of screw up people really often. This is unfortunate. Remember everyone, you don't need labels to describe yourself. Define yourself by who you are. Similar to how electromagnetic waves increase energy when they have smaller wavelengths. Actually, all waves increase in energy when they have smaller wavelengths. That's simply because this is actually increasing frequency. That's how we can think of it. If you want to increase frequency, then you need to increase the speed at which waves happen, basically. And as you increase the speed, you need increased energy. That's how we can think of it, at least. That's why I think of it, because the most convenient. That's why all waves, that's why it's a pattern in physics where all waves require more energy to have smaller wavelengths. Study integrate. Ah, that does make a lot more sense. Not immediately appreciate the normal scale of these energies. Energy of one volt is about the same as kinetic energy of 1 gram particle moving. Oh, that is insane. Oh my goodness, that is insanity. Holy moly. So energy, that's an energy of a quark, correct? Oh, that is insane. Hold on. That is insane. That would mean energy of 5 quarks could accelerate 1 gram to 1.7 centimeters per second. Oh, that is insane. Doesn't interacting with chat distracts you? Not really. Not really. I like it. Keeps me motivated. I like chatting. Oh, that is madness. That is ridiculous. I guess it makes sense. Still, ridiculous. Absolutely crazy. It would find it very hard to gain such energies, and they push back going on the grasp of. Accelerator of a combination of electric and magnetic fields is easy to get necessary power as well. Okay. Accelerators in 2 ways. One, which particles accelerate on string lines or along approximate circles. The other distinction will use DC, AC voltage, in case modern accelerators. Okay. Alright, so a straight line or circle, and then a DC or AC. I am struggling with this, why DC AC matters, but make it. Do you do biology explanations? Not really. That's mainly because the models are really difficult to make, and if I were to buy them, they are really expensive. Clockwork on YouTube does really good biochemistry videos, I do have to say. I don't promote other creators often, but Clockwork has around the same size of its channel as mine, and they do really good work. Clockwork is basically what would happen if Make It would specialize in biochemistry. This is really good. Like these kinds of... Man, hey, that's really amazing. What we're doing right now, actually, research hydrogen granite. Yes, we're doing research, some basic nuclear physics. According to human perception. Yeah, but in this case it's even stronger because, you know, the as scale decreases, energy increases. Make it. How to study from a physics textbook? I honestly wish I could answer you. I'm struggling with this. This is the first page. Hydro happy. It landed on tails. No, it landed on heads. It very much landed on heads. I'm so sorry for, you know, I really have a page. Make it good together. See, everyone voted heads. And thus the video was deemed heads. Basic goes to quantum mechanics. Okay, to be fair, this is basic nuclear physics. I don't like to pretend as if I know more than I actually do. Like, this is basic. How'd you sleep from yesterday? Very peacefully, thank you very much. Actually, the reason why I called this stream enough, you know, time to get back to work. And why I called it enough rest, time to go back to work, is because I actually slept in today. I slept for, I think 10 hours or 11, which is pretty long for me. even 12. And so I slept in. And so that was my rest. And I'm done with resting now. Time to get back to making a video. Make some paper and use it. Theorem. I was so cool and so rad. Only later realized it only saved you 2 steps of calculation. Hey, listen, just because it only saved you 2 steps doesn't mean you're not. That's still cool. Using a whole theorem just to save 2 steps of calculation that's a very applied mathematics way to do it. Not to everyone who has used a physics book to study knows how important it is to not use a physics book to study. 3 hours. Only one patient. Hi there, I'm awesome. Hi. Acceleration this is rather straightforward. You have to back between them, but okay. Technical Nobel Prize. I see. So we have better system is not a generator, even though this technique is slowly becoming obsolete. Nuclear physics, technological applications are very common. The basic idea is non-conducting, run and build, transfer charge with collective machine. You can build this sort of 20. Okay. 20 mega. That's a lot. I guess it makes sense. Little particle accelerator. Okay, I see. Your dream behind your sharp focus on reading. Am I focused? I keep getting distracted. That's a bang graphic. Okay, I see. So negatively charged ions. At positively charged ions. Okay, this is still already quite complex, even though it's very obsolete. Make it. What tech do you think is going to be popular or used quite a bit in like 2030 year? Renewable energy. That's an obvious one though. So, you know, I don't know. That's what you meant. But renewable energy and general automation of everything. I know that automation is an extremely general way to put it, but I do believe general. Oh, also 2030. 2030 is not that far away. It's 6 years away. If you ask me like 2040 or 2050, now it could go with rockets or space travel or, you know, more satellites, this time habitable satellites and so on. What did you go for the video? What are you trying to tell people who watch a genuine question? Well, with this one, I am trying to explain that chemistry isn't as scary as most people think. And that chemistry is actually extremely intuitive. You don't need to memorize a whole lot. It's extremely intuitive. It's extremely simple. And you shouldn't hate chemistry just because it was improperly explained in schools, because most schools absolutely awful at explaining chemistry. And this one is just for fun. Just be like, hey, look, these different forces. By the way, Make, should I invest in petroleum stocks? Oh yeah, you know what? As much as I think it's a great idea to ask a YouTuber if you should invest in something, I don't think I have quite the expertise. Do so much for me. This was. What's popping? Hard Ninja. The explanation coming through our questions today. Oh! Yeah, Flame is great. Flame is certainly top 10 people. So how much isn't as bad as you think? A theoretical title. Well, the title will be Why Advanced Chemistry is Easier. That's going to be the title. And it really won't be quite like, you know, chemistry isn't as bad as you think, only chemistry is awesome. That would be the gist of the video, because it really is. There are a lot of people who love physics and absolutely hate chemistry, and I understand it, I get it, yeah, people hate chemistry because of how it was done in schools, but in reality they don't realize just how close chemistry is to physics. And sort of the point of this video will be that for every single flavor of science, every single one, the way it's normally taught is not Intel. What the heck? How did you even open up Intel? That's, you know what? I don't even paint. I don't even have an Intel CPU. Why did I you know what? I digress. The point is, for every topic of science, there are basically, it can be divided like into two stages. The first one, which is the basic one, and then the advanced one. In the basic one, you're just learning the basic gist of it, you know, getting the understanding behind basic topics. So for example, in physics, that would be force in newtons, that would be mass, that would be basic mechanics, right? So you have a particle, how it's moving, that would be maybe some angular mechanics, you know, how it's rotating around stuff, and stuff like these. But then only as you go on, then you learn all the specifics, you know, then you actually have to memorize stuff. Even in physics, you have all of these equations, you have different theories for thermodynamics, for quantum mechanics, for relativity on large scales, relativity for nuclear physics, then, you know, then you specify. And that's how things normally go. This is taught in schools, this is taught in colleges and universities. When it comes to chemistry, however, it's backwards. Well, not quite backwards, but kind of backwards. Where on the very beginning, you're sort of learning about ways to apply chemistry. You know, memorizing equations, memorizing reactions, memorizing oxidation states, which I really don't like. Electronegativity, both which I think are idiotic way to introduce someone to chemistry. And so basically, it's really weird to me that when it comes to schools, when it comes to physics, you're starting with basic understanding, then you're moving on to the specifics. When it comes to chemistry, you're starting with the memorizing different ways to do reactions, which would be really convenient if you're actually trying to apply your chemistry, or if you're trying to specialize in chemistry, and only then moving on to the intuitive bits. Hide the flame, speak of the chemists and they will appear. Actually, we could just move on, we could just switch to chemistry. I've been just doing nuclear physics, I'll be honest. Oh, that was a really long rant, I've missed on so much. Also, I should, I don't know about this one, because right here with the second one, I did want to throw in something on a larger scale, because I don't want to just do theoretical chemistry throughout the entire video. This is going to be the most theoretical chemistry of the topics, and this one is going to be pretty theoretical chemistry. This one I wanted to change it up a bit, do something a bit higher scale. It's not going to be organic or anything, but yeah, I at least wanted to do something on a larger scale, something more akin to actual chemistry in schools, which is states of matter and different kinds of bonds, and why they matter. Oh, why different kinds of bonds matter. Much better name for it. That's a pun. You like chemistry more or mathematics? I couldn't pick, even if I wanted to. I just don't have it in me. My genetics just don't let me. Hi the flame, by the way. So sorry, I was out on a rant, you know how it is. Need any chemistry help today? I genuinely don't know. I feel like we should set up one stream when you're free for help with this one, because right here I do want to get over excitement of electrons and how photons interact with them. But I don't know if today is the right one, because today I did want to research a bit of nuclear for the fundamental forces video. This video isn't done today, so that's because I want to spend them. So yeah, bye Turbulent, bye. It's fine, I don't think the video is gonna be done today. I've mentioned them about twice and Flame has been there both times. Yeah, I don't know what to tell you. It's the curse of the blue nickname. Ashad, one day maybe you'll get a blue nickname and you'll see that when you get a blue nickname, whenever like a topic in your field of study is mentioned, you just get yoinked into the chat. It's not really a choice of yours. You're just there. Black magic. Well, I would say more ritualistic sacrifice, but you know, potato, potato. I want to improve in organic chemistry. Oh boy, no. Tough crowd when it comes to me. I am awful with organic chemistry. Only atomic numbers though. That's so many elements still. Like when demons get summoned against their will if you say the right words. Exactly. Actually, no wonder demons are so pissed whenever they're summoned, you know? Now I'm thinking about this, yeah. If someone yoinked me out of my office to be like, hey, do this for me, I'll be pretty pissed too. I've never ever seen you try Organic. I did try Organic a while back ago. Didn't like it. I did on streams, not in videos though. Should I make an... I could try for this if you want. But I would need a solid topic to explain Organic, and can't really think of any. Acidity? I already... No. No, acidity is not organic enough. Carbon. Benzene? Oh, no. Too small. Basic. Benzene could be a good example though. I mean, maybe when it comes to states of matter, carbon chains, how they affect the states of matter will be a bit organic. I'm having trouble tying it into anything I could mention. Organic is difficult to explain because there's just a lot. There's a lot of information there. Carbon chains. And then more... Oh. Actually... Oh. I could do organic. Carbon stuff is for our video. The problem with the carbon stuff isn't really that the video would be really long, only that it would be really boring. Because it would be mostly just me naming things, rather than explaining the intricate ways in which they operate. But the why carbon chains could be something. Because there is a reason. Carbon is, let's just say, extremely convenient. It's an extremely convenient element for organic chemistry. There is a reason why carbon is... It's always carbon, nothing else. And it's obviously always carbon and hydrogen. And that could be pretty good. Oh. That's a maybe. That's a gosh darn maybe. That might be... A lot of organic chemistry is very visual. Yeah, but it may be very visual, but it's also very boring in these visual stuff. Except for... except for supramolecular chemistry. That's just idiotic. That would be pretty funny. Oh. That would be a pretty funny one to visualize. I'm gonna include this bonding in different kinds of bonds, because it's so dumb. I guess a section on transition elements and how they're used as a catalyst everywhere in industry, because that would be sort of applied, like, if you want. Transition elements, what? Not quite. Okay, for this video, the point is that I'm taking something that's being taught in an extremely awful way in schools and trying to find a different angle. An angle which explains it a bit better. So, for example, why reactions happen using electrons. What are states of matter? But instead of just exploring the basic three, I'm actually explaining why they matter. That's funny. Light. That's because... Okay, That's just because atoms interact with light, and I thought this is pretty cool how it works. Why carbon chains? That would be good for organic chemistry. Make it. Do you remember that -1 someone did point out in the recent video? Oh, not someone. A lot of someone's. There's a lot of comments under that video, all telling me that -1 is just -1 because I forgot about the brackets. There is a non-insignificant amount of someone's. Can I somehow filter comments, or is that not a thing I can do on YouTube? Oh, let me see. Let me see if we can count how many there are. There's a lot. Oh, there is filter. -1. Okay, so there is a lot. Alright. Four modes. The problem thing is top of 2 points that the function might get the weird stuff between them. That's not something I can read right now on stream because that's a lot. I will have to read this later. Then we have -1 is equal to 1, -1 is equal to -1, of course. But you forgot parentheses get around -1. Yeah, this one, once again, -1 is not equal to 1 Isn't that supposed to be in the brackets -1? There are a lot. Supramolecular chemistry, man, that is something. That is weird. That is bizarre. That's ridiculous. That's not. that's engineers playing chemists. That's chemists, except they don't know when to stop. That's people who don't want to deal with theoretical chemistry, still being like, oh yeah, I don't need to hold my beer. I'm just gonna like using a Lego block. I'm speechless. It's idiotic. The pictures are so idiotic. I love it. A small mistake, but yeah, I mean, a lot of people were on that stream, and everyone was yelling at me to add in the brackets. I just thought it was funny right then. Valid field and mechanical chemistry. That's a bit nuts. Oh yeah, sorry, mechanochemistry. Right, sorry, that's on me. Yeah, because supramolecular is just around molecules. I mean, not around molecules only. Well, it's in the name. Quite irrelevant. Still, putting a chlorine atom in a cage, it's hilarious. Mechanochemistry is basically mechanics, but on a molecular scale. As the name would suggest. Which is actually really cool. The fact that we went from, you know, massive gears to just making mechanisms on scale of atoms, it's pretty awesome. Said make it whilst reading literally about particle accelerators. Oh, single molecules. Hold my beer. What about single particles? Do I need to know about this actually? What's interesting it may be. It's not. I don't think I'll mention the video. Okay. Interesting as it may be. Won't be topic of the video. Hi, the Cup. Welcome. It made me curious. It's really fun. Funny. I don't know if it's fun. I haven't researched it in any way. I've just seen the pictures. It's funny. Particle accelerator, my research involves building one. Oh yeah, it really does, doesn't it? Well, to be fair, I did just skip over them. I think I could go for it if you want. That's why I've skipped over it, because, you know, I already know how a particle accelerator can function. See, that's why I did it, because I already know. Oh, this is fun. Whose idea was it to pick research interactions 57%? That's barely a half! I blame all of you. I blame all of you for picking this. Ah, democracy strikes again. Wait, hold on. Experimental tools. Oh, that's obviously not what I'm looking for. I'm an idiot. Detector. I've already been over this. I'm such an idiot. Nuclear, yeah, from 3 to 6. I'm such a bloody moron. Damn it. Okay, each nuclear positive charge and each number neutral. Of identical charge coming from mass and approximately multiples of the nuclear mass. Okay, simple enough. Why are these so short? That's terrifying. That's not a good sign. Is this like more of a review textbook? Because that wouldn't be great. We're gonna nucleus of contain Z positive charge neutron probes. These bond together nuclear force, which changes the mass, build out the free particles. Okay, makes sense. This is actually a really cool topic. Delve more in depth about how, since mass is so closely tied to energy, actually on the molecular scale it sort of breaks away from what we in classical mechanics consider mass. Mass is even better using it, which is 1/12 mass of neutral carbon atom, because of course you just had to set up a completely arbitrary unit. I'm fine. I'm done. No, I'm done. I will not go into arbitrary units. That's it. I'm just gonna play a couple much of nice with science stream. Oh no. Flame, this is nuclear physics. At best, it's something you know. At worst, it's gonna be really boring. I don't want you to not play Valorant just to sit here. That's putting pressure on me. 60%. I blame every single one of you. Hydra kill! Welcome, Hydra in there. Did you get the broom closet ending? Broom closet ending was my favorite. Broom closet ending. What kinds of all chemical reactions take place? Energy and entropy. Oh no, wait. I'm guessing it's a multiple choice, isn't it? Wait till you hear about nuclear chemistry. Why do you all do this? You chemists. Just picking every single field of physics. Slapping chemistry on top of it. Claiming it yours. Even mechanics wasn't spared. I am skeptical about this textbook though. It seems a bit too simple. It's scary. Burning energy. Find neutral atom. Yes, exactly. Same temperature. I do believe it's, unless I am a big stinky dumb idiot, it would be physical contact. Yes, same temperature. Nuclear binding energy versus nuclear number. Apparently. Mass binding energy defined for a neutral atom was the difference between the mass of a nucleus and the mass of its constituents. Okay. This is one of these fun equations when it's completely unreadable. When B is greater than 0, when the mass of a nucleus is lower than the mass of its constituents. Okay, so we have... Oh, okay. Tandem can ignore that until university. That's a really common thing in chemistry, isn't it? You have all of these obvious rules, which it wouldn't really make sense for them to go any other way, and then you're like, well, actually, you see, wait a couple of years, and then you'll see how they can be broken. Physical contact? No, they can teleport, you see. Actually, not even teleport, they can just exist in different places. What would tunneling even be? It's not teleporting. Because it's a probability, they just exist. They kind of exist. They probably exist somewhere. they probably are in a different spot. How can neutrons just gain to one proton and electron when unstable isotope? Oh, that's nuclear. Oh no, that's nuclear physics. Haven't gone that far. I'm so sorry. Biology is applied chemistry meme, and see the pictures quite suited here. I am going to look it up in the new tab. It's not that I don't trust you, I don't trust my browser. You mean this? That's the question. That is weird. Same temperature. What could that possibly mean? What conditions required for chemical reactions to take place? No, I'm just gonna leave it in capable hands of Flame. I have nuclear physics to get back to. System is born mass nucleus low in mass of constituents, not quantity nuclear as a function of A. Okay. What if, hypothetically, crazy idea, I don't have memorized all of these. Actually, Ashad, would you happen to know the standard for all of these letters? Could you help me out real quick? Would you mind? Would you happen to know maybe what of the standard? Because I'm assuming it's a standard, right? It's not just arbitrary letters that the person wrote this textbook put in place for all the masses, right? Resolution of the stream. Oh. There we go. Either with me. A and Z stand for nucleon number and proton number. Ah, that's exactly what I was looking for. Thank you so much. Ashad, want a blue nickname? I deem it enough. You know stuff. That's good enough for me. There, you've earned it. There we go. Congrats. Welcome to the blue nickname gang. Welcome to the elites. Temperature, chemistry, logic. No, I feel like no. In this case, this is a grade 10 chemistry. equations reacted faster in chapter 1. The thing is, the kind of chemistry you're learning, Lohit, it sits in a pretty awkward spot where it's sort of in between any specific field, while at the same time it's trying to give you a good understanding of how to do chemistry. And because of that, all of these questions will be vague, and these aren't really questions of what happens always, only what should happen most of the time in the topics we've discussed, or in the examples we've discussed. So the me knower of things, exactly. Now carry your power of responsibility, however that saying goes. You can't experience love. What do you mean by that? Like, I can't experience love? Boy, that's it. Oof. Whoa, what a way to change the subject, huh? Olo, that's a bit... Listen, we're already struggling with nuclear physics, okay? That's enough. Nuclear physics is already depressing enough. About to turn 72. Yeah, now you'll see how whenever make it asexual confirmed. What? No, I love having sex, you know? Oh, actually, I have a nickname. I don't know if you, but like, most people call me Make It the Sex Haver. That's actually what most people call me. You wouldn't know it, because it's not the same, like, social sex, but yeah, that's what most people call me, asexual? Come on now. What? It's ridiculous. It's mass defect. I mean, if A and Z is the nuclear number, proton number, if A is nuclear number, Z is proton number, then it is kind of self-explanatory. Actually, you know what? If you can explain the entire passage, go for it. You know what, Ashad? I'm not above just depending on others for understanding a textbook. If I can just give up, I'm all for it. I have no clue how you count the quantum numbers of an element. Like how many customers looking at periodic table? Yes. Woomy! Oh my goodness, do I have a video for you then? Woomy! Oh, you're gonna love it. Oh, you're gonna love it. Oh, Woomy. Whoa! I've been waiting for months. Yes! Yes, Woomy, do I have a video for you? Do I have a video called Everything About Electrons, with the third chapter being quantum numbers? No, Flame! No, don't send it to P-Table, no! Send it to my video, which I made using P-Table. In this video, I do believe I mentioned P-Table.
You have to understand by that. If we recommend it,
Hold on. Did I mention P-Table in this video? Did I not? Blasphemy. I thought I did. I stole this graphic from P-Table. I better have mentioned it. Did I really? I was so certain I mentioned it. I didn't even link it. Oh no! Was it not a video? It might have been the sulfuric acid video, or one of the first iterations. That's awful. I'm changing it right away. How come I can't notice such a long time? Alright. 8:36. I need to add a card of ptable.com. For things to come together and the molecules spread must be to some respective but the mass must actually less than that. Theoretical mass is 10 to binding energy, divided by the number of nucleons, again by the energy per nucleon. In order to separate nucleon of that atom from nucleus, you'd need that amount of energy, binding energy per nucleon. Okay. Mass defect basic form. Alright, so... So if we want to separate the nucleon, then you need to use the mass of the nucleon in that atom amount of energy in order to get it out. Or the molecule? It's a molecule. Atom, no, it's an atom, okay. Applied physics, which is applied math, which I like to think is applied philosophy. Yes, I would also recommend going on Discord, where Flame has a whole channel just dedicated to helping people with chemistry. And the reviews are in. Flame is goated. That's not me, that's just me quoting. Flame is a goat, also was there. And also Flame is amazing. That's the third one. I'm trying to add in the P table because I really messed up. I stole this, you see, like the thief that I am. This right here, I've stolen it from P table in electrons right here. It's the exact same graphic. To be fair, no, there's no to be fair. This is just awful. Damn it. Cards. There we go. 856. Zero 856. Oh no, wait. Link, this link, P table, sweet. There we go, save. Make it WTF account setting is out of date. Oh no, whatever shall I do? There, consider tab added. I no longer feel so awful. Ah. The energy is what you need in order to completely separate all the nucleons of the atom. I see. Okay, so it's just the mass that's been converted into energy. Okay. Think of it like taking something away from the air and how gravitational potential works, or how taking a point charge away from another charge works. Right, you separate them to infinite distance. So in this case, part of their mass gets turned to binding energy. If you want to separate, you need that amount of energy in order to turn that binding energy back to a mass of a nucleon. Well, moderator in this case doesn't really matter much. It's not really moderator, it's just people that I've deemed knowing enough of different things to help me. What music do you use in your videos? It's AI generated. A long time ago I've made something called Make a Theme. Which was basic chord progression turned into a really basic song. And then Soda made their own version, then Tefta made their own version, and then I just remixed it with AI. And that's why actually for every single song you hear in the background, it has the same exact theme. This one. Yeah, and that's why every single one of them has the same exact theme in them. Good, yes, really is. I think how difference in binding energies of different atoms causes release in energy, fusion, fission. That will hopefully be the next step. What's the day count for? To remember which day it is today. How long I've been streaming for already. I don't think I need to explain. This is just pretty self-explanatory. I could keep going, actually, for a solid couple minutes. Oh, one of them was a medicine research stream. That was a long time ago. Oh, the subcutis. And even electricity. Boy, those were the good days. They were not. I've played Half-Life though. Half-Life 2. That was pretty solid. Do not allow in social rooms to hate. Social as in social media? Social as in the social society in which we live. Essentially to you saying that you can't experience love. Are you a psychopath? No, I'm not a psychopath. Normally I would be really upset that you say that, but to be fair, you can't experience love. It's not that I can't experience love. Okay, I do experience love. I love love. I love love. You can't love love without loving. I can't experience love. It's just I don't really... It's not can't as if physically unable to. It's can't as in shouldn't. Damn the English language. I blame the Brits. They have should, they have will, they have shall, they have would, they have could, but they couldn't separate the can. Scared that there will be too many wars, huh? Actually, maybe the Germans, I think. I think that might be... Actually, I think that might be from German. Or French, you know what? I'm all for blaming the French. Yeah. Any addiction questions? Oh, I think that's... Okay, never mind, I don't think that was to me. By the way, did you all hear about the fact that England could have been called Sexland, unironically? England could have been unironically called Sexland. And we just missed out on this. Because of Anglo-Saxons. If it wasn't the Anglo that made England, then it would have been Saxons. And if the A got replaced with the E, just like with Anglo, then it would have been Sexland. Shame. Most of your audience knows it. Yeah, but I don't. I would love to, but I don't know it. Also, most of my audience is American, actually. Not most. Only the biggest demographic is Americans. And I don't think Americans know Hindi. Nobody there has game. Wait, what? Why specifically England? Nobody there has game. Oh boy. Wait till you hear about Flame. As generally clean cars, countries closed. Oh, that's actually fairly common throughout languages. It's actually, I'm pretty certain English is the odd one here. It's pretty rare for languages to not have that. I have a lot of views today. Yeah, because I made a video which blew up. Best performing video of the channel. That's why. By the way. Remco! Oh, speak of the physics. And there he goes. Bye, Remco. Like everyone. Yeah, most languages actually have them. Yeah, Ash got promoted into the elites. Because he has knowledge. That's what we need. There's a new mod. It's Ash. Ash been here for quite a while. And Latin language has them. Oh, that's probably why. Okay, so right here. Oh, I think I get it. Wait, why is this much? No, wait, I do get it. Do I? The mass is a function of A alone. Furthermore, the... Okay, so of A. Mm-hmm. Nuclear saturation. Ah, put that in our back pocket, because it might be important later on. Give me a second, I'm getting a phone call. Be right back. Nothing like more work to do, am I right? I'm back. Fortunately not today though. It's already a 6 more popular video on the channel, yeah, it really is. What do you specialize in? Videos that the subject of physical studying theory. Isn't interesting. I actually don't specialize. That's the gist of my channel. I refuse to specialize. That's why we have videos about physics, chemistry, mathematics, computer science, programming. Soon you'll see. Foreshadowing. Ah, the feds called them. Okay, so nuclear saturation seems like something important. I should put in the back pocket. Consistent with saturation hypothesis may become in the 30s. That was well, but as A increases, the volume per nucleon remains constant. Alright, so A. Wait, is A the proton? Is it or the nucleon? A is the nucleon, correct? A is the nucleon. Alright, so A is the mass number. Mass of the atom? Number of nucleons. Okay, good. I really don't like the fact that both of them are like connected in such a dumb way. Okay. A, number of nucleons. Which means that as A increases, the volume per nucleon remains constant. Okay, makes sense. I mean, it doesn't, only it provides new information, which is curious. So, as A increases, as we add in more nucleons, the volume per nucleon remains constant. Which means, we chuck in more A's, the atom is getting sufficiently bigger in order for the density to remain constant, the nucleon density. Okay, for a spherical radius, nucleus of radius r, we get the condition this. Pretty self-explanatory. Wait, yes, pretty self-explanatory. Or this, if we rearrange it, from which we conclude that volume is equal to. Cool. Sweet. I'm big swimming pool for sulfuric acid. Yeah, the tiny amount of the pool making it very dilute sulfuric acid. Function becomes in, yeah, okay. The massive function of A alone. Wait, so if we add in more protons... Hold on, so if we add in more protons, that mass just gets turned into binding energy? Or do they mean something different by... So to a reasonable degree, approximation the mass function of A alone. Part of it does. Why would the approximation of the mass be a function of A alone? I'm really confused about what that means. Approach is a constant. Nuclear situation. Okay, so... Alright. Makes sense so far. So far it all makes sense. Except for that one bit, but I'm saying I'll clear it up sooner or later. Can you tell me if being good in social science until grade 10 stuff was useless because I can't see a proper use for it? You should never think of something as useless just because you can't find a proper use for it. That's never been a good idea in science. No one knows if something is useful simply because they can't find a good use for it. So don't think of it this way. Think of it in a different way. Do you like it? Do you enjoy it? Do you find it interesting? And do you find it thought-provoking? That's my... I know it sounds corny, I know. A bit cheesy, I get it. But it's the Lord honest truth. There is more section for simple linear dependence. Following terms should play a role. Bulk energy. Terms have both saturation and energy proportion. Okay. Surface energy. At the surface of the nuclear sphere, have less neighbors should feel less attractions. The surface area goes so far. Okay. Pauli or symmetry energy, Coulomb energy. Makes sense. Yeah, atoms ain't as simple as they seem. I get it. Of this get there, we get this formula, which I won't even attempt. I mean, it's all these combined. There's no point. What's cheesy? My take on the matter. Why shouldn't you love? Miss Sun the next night. 2 more times, then I give up. Although you're making it very difficult for me to avoid the question. You know, it's pretty mean. I am trying so hard to avoid the question, and you like keep going. That's... Come on, mate. Let's just say I wouldn't be great in a relationship. I'm an annoying person to be around. So that's why. Simple. Makes fun of me for that exact reason. What reason? Reason being you do social science? Don't let the haters get to you. Energy with A grade in 16. You can't be sure that someone wouldn't love that, can you? Oh, no, yeah, obviously I can't be sure that someone wouldn't love that, but what I can know is that I am toxic. That's something I can know. I'm not here to... I'm not saying that no one could love me, I'm saying that no one could... You're making it very sad, you know? Although, come on, mate. Had such a lovely light-hearted stream, learning about nuclear physics, having fun. I've had a very toxic personality. I don't want to be toxic, but I am. Physics, history, geography. Eat some basics so that will make you basic. I love basic stuff. Basic stuff are basic because they're good. Everyone likes them. Although, I can't know what to tell you. I'm just literally Ryan Gosling from that one movie. I won't tell you which one. Radioactive, in which you everyone's strong bond towards you. Failed attempt at lightening the mood. Not failed, I wouldn't say failed, I would say that's pretty funny. How the fit works. These remain certain structures, even though the strong difference between the nuclear is the superfluid nature of the nuclear material. Nucleons of opposite momentum tend to anti-align their spins, thus gaining energy. I forgot this nuclear physics, okay. There's so many different Gosling movies, yay! Actually, oh, that's a great conversation starter. Whenever I'm introducing someone new, when you ask to introduce yourself, I could always just introduce myself as, oh yeah, I'm just like Ryan Gosling from that one movie, but I won't tell you which one. That's good. This is a banger illustration, actually. I like it. Are there more Gosling or more movies featuring Gosling? All movies featuring Gosling are... That doesn't mean Gosling as in the geese stuff. Be toxic on stream. No, that is actually... Oh boy, I'm going to get me into... Come on! Are we really going into it? Want me to be toxic on stream? I am toxic on stream, that's kind of the point. Here's the thing. Right now. No, this is depressing. I don't want to get into it. No, we're getting back into nuclear physics, for goodness sake. Do you mean you are straight? You're straight in all those movies. Was he? Oh yeah, I guess. Yes, he was. I didn't say I'm literally like Ryan Gosling. I mean, he is just like me for real. But I'm not literally Ryan Gosling. I wish I was. Focus, make it. Exactly. Yes, I need to focus. Thank you. No, thank you. Getting us back on track. I'm sorry, I've just been daydreaming about Ryan Gosling. It happens every now and then. Okay, so the point of this subchapter would be, well, so far, really complex. Again, this graphic is a banging graphic. I absolutely love it. And then getting this all together, energy is made up of all of these together. So we have alpha A, so alpha, beta, gamma, epsilon. These are all non-normalization constant, only the other ones. For charity. I don't want to get into it. It's upsetting. I'm not saying I am toxic as if I am hateful or, I want bad things to happen to people. It's not really something that it's the consequence of my lifestyle. I kind of was gonna go to picnic. Bye, Lochid, have a good one. Good luck at the picnic, and see you next time. Stop suicide by being toxic. That's, well, I suppose the method, I guess in this case the results are what matters. Good for them. Oh, and right here we have how much each one matters. Oh, that's good. Okay, so right here we have all of the different interactions that can happen. Love acidic stuff, like drink soda, for example. Not quite. What I mean is that Have you ever seen the show House? Have any of you all ever seen the show House? Yeah, well, basically, I have a similar lifestyle. I'm like, if House wasn't a pain in the ass and less clever, that's basically me. The thumbs. That's the lifestyle I mean. I'm not like eating and doing stuff, I'm healthy. Mass number of those are more abundant. I mean, this is one that seems like a lot. But even though all the parameters remain the same position, making us fit the formula. Okay, so this is the formula for the energy of an atom based on the amount of nucleons and protons. I see. And I could just decipher what all of this means by going right here and figure out what all... Okay, so we have bulk energy, which is the first one, which is just nucleons. Surface energy, which is minus... Why minus? All of these are minus. I see. Cool. Minus beta A. Okay, surface are R squared. Less neighbors should feel less attraction. Okay, so this is subtracting because... okay, so this would be like the general energy of the nucleon. And then right here we have to account for all of the problems with that general energies. For example, some of them on the surface, they don't... Obviously on the surface they will have less. Some of them are occupy the same states, thus reducing the binding. Some of them are asymmetrical, let's call it, and which thus reducing their energy even further. Some of them is Columbus screwing up. Okay, good. I think I get it. I'm not gonna memorize it, not even close. I'm not even gonna attempt. Because that's not the point. What is the formula for finding a girlfriend, man? Being social, being nice to people, having an interesting personality, being funny, quirky, and finding someone who shares in your interests. You shouldn't think of it as finding a girlfriend, because that's an odd way to think about this, in my opinion. Just go out, look for friends, try to get new contacts. Let's find out where making lips. Whoa, that's it. That sounds like a threat. Expect a girlfriend to find me. Ashad, listen. Well, I guess. It's a mindset, I suppose. You know what? Good for you. Who am I to stand in your way? Expecting curve. Okay. Mass, by their mass, red to those lowest mass, from magenta to those highest mass. Okay. Nucleon are most suitable. Most stable for fixed A have more neutrons than protons. Large A increases them for... Okay. Large A. Neutron X. Okay, so... Stability, alright. Red lowest mass. Magenta highest mass. And so... No, come on. A is equal to n plus z. No, evolve, I guess. Yeah, it's ballsy. But you know what? Self-confidence is important. What's really screwing me up is I don't have the letters memorized because it's been ages since I done research on the topic. Atomic numbers, characters. Giving life advice, thank you, bro. I mean, you know, at the end of the day, it's what matters. In my opinion, you shouldn't think of it as finding a girlfriend, only finding people you like, and then one day there'll be a spark between you and one other person, and there we go, congrats. Atomic number Z. This is ridiculous. Okay, Z is the atomic number. Which means atomic number plus... This is neutrons, protons, correct? How life make it, live streams work, yeah. It's always how we always oscillate between life advice and quantum mechanics. Or nuclear physics in this case. Alright, so Z is all of them. N protons, A neutrons. I think. I'm not certain, not confident on this. Which means these would be the most massive. This would be... most protons? Doesn't make sense. A is total nuclear number, Z is proton number, and N is neutron. So A is all of them. That completely changes the meaning of this then for me. So A is all, Z is proton, N is neutron. Okay, N and A, easy to remember. That's all. Okay, that makes a lot more sense now I think about this. Oh my goodness, that's so much simpler now. That's why Coulomb has... Okay. What I'm screaming about. I've misunderstood. Alright, so on one, that makes almost sense because right here then we have protons and neutrons, okay. So, generally more TLDR, oversimplification, more neutrons can be more stable than more protons. More protons, less stability, yeah. Yes, so more neutrons. Yes, so more neutrons. The same A, yes. So more neutrons are more stable than more protons. Nuclear number A of masses very strongly. Alright. Hypertext, but it's really cool. It's really awesome. Mass of a nucleus with a fixed nuclear number, A, rapid burning fast true value of stability. You can see that masses very strongly. Okay. A is fixed. Which means as we add in... and this is the amount of protons. Hold on. So as we add in more protons, we need to remove the neutrons. And as we add in more neutrons on this side, we need to remove the protons. Because A is fixed. This A is fixed. And so the mass is somewhere in the middle. Which makes sense. Yes. The Goldilocks zone. No, a free neutron is not a stable particle, and it actually decays by emission of an electron and antineutrino. Oh, we've got that. Cool. All right, so neutron decays Electron, antineutrino, proton, correct? Rewiz. There's okay, I gotta say, there's a lot of characters here. I don't love how many characters are happening at the moment. I get why, but still. It's endothermic. Okay. Makes sense, I think. Yes. And then we need this because energy can't just disappear into the ether. Oh, this makes sense. Okay. Right? That's it. No. No, it doesn't. Yes. I'm wrong, but this makes sense. Neutrino has no mass. Okay. Allowance of such reactions per Q value, the amount of energy released in such a reaction. Okay. Which is basically the original minus the two of them. Once again, makes sense. Traveling metro. Yeah, welcome back. We're just doing basic nuclear physics. Alright. This is so clear. Oh my goodness, this is lovely. This is amazing. Oh, this is so amazing. Okay. I will check this complete. Alright. Hold on, give me a second. I have a lot of messages, mostly from bots. I'm assuming you mean this one. Oh, I see. Thank you. But I do believe I cracked it already. I am clever. I can remember 3 letters. Is this nuclear physics? Yes, it is. This is lovely. Generically, is found that 2 reactions based depending on the balance of masses. Either a neutron beta decays, sketched above, or we have an inverse reaction in which a proton. That's positron, correct? I think. What specifically? Oh, this is just an introduction to nuclear physics. So right now we're going through decay. The electron and positron emitted in such a process called the beta particle. Beta minus decay of nucleus of Z proton and a neutron turns into one of Z plus 1 protons and then minus 1 neutrons. Because move to the left since that figure and the mass is Q, the factor is. Okay. This is fun. No, I'm having fun. I am enjoying myself. This makes sense. That's nice, at least. The nice thing is that it makes sense. We can go back and forth, obviously. Cool, thank you so much, Windows, that you're informing me that you haven't found any threats. Instead, the fragment of the reactions where single nuclear neutron proton is emitted, complicated such as helium nuclei of particles are emitted. Q values, okay. So, oh my goodness, okay, so when it comes to decay, like alpha, beta, whatnot, it is just... I see, gee, that makes sense. That's so nice, wow. Alpha emission, so alpha emission really would be just 4 and 2, so that's helium. I know all the symbols though. Well, you're right, you were right there with me. 2QB formula. You mean these ones? Yes. I just skipped over that. But this makes sense. That's amazing. So alpha emission, the one, let's focus on alpha emission because I remember that one. So alpha emission, I do believe this term is here because of proton minus m. Well, it's certainly because of the two protons, right? That's why the 2me. I think this is because in this one the decay is... No, it doesn't make sense, does it? I actually don't get the top one, if I'm to be honest. The bottom one kinda makes sense. Stuff like lithium if we wait long enough by decay. I think so. I do believe actually lead from uranium present, that's the good example, but yes, this is more detailing like why that happens. And the reason why it happens is because, well, you can get energy out of it. Count for. Yeah, I don't really get the top one. Oh wait, isn't the top one just the backwards one? No. Yes. Oh, I think electrons should be emitted, there's an equation. Oh no, I think the top one is what you need. I'm pretty set. Oh yeah, right here you'd have negative energy, I think. Would you? I think right here, that's the energy you need in order to turn a proton back into a neutron using a positron, I think. Not certain, don't quote me on this, I'm still trying to figure it out. For historical reason, the electron-positron emitting such process called the beta particle does in beta minus decay of a nucleus of Z protons and N neutrons turns into one of Z plus 1 protons and N minus 1 neutrons. No, wait, then this would be the... If it's minus 1, no, plus 1, then it would be the top one. What? No. Doesn't beta minus decay of a nucleus. So this is nucleus. Okay, this is certainly Z minus 1. No, this is nucleus. This is proton nucleus. ChatGPT as well. No. We're smart. We're clever. We can figure this out. To be fair, we don't need to understand that reaction for the video, so... Well, not that reaction, that single equation, actually. What's the problem here? The problem back here appears to be that we have the decay of a neutron into a proton, and then decay of a proton into a neutron, sorry, why I say so weird, neutron, and one of them requires the energy. Oh wait, am I going backwards? Minus. Oh yeah, we want the new energy minus the original one. Correct? No clue. I'm tempted to just give up. And I might. And I shall. Okay, quantum numbers. Oh, yes, spin! Yes! Yes, finally! Took me long enough. Variance, loss resistance, rotation variance. Physics not dependent of the direction you are looking at. This leads to a vector of a vector angular momentum operator. A proton is made so electron is emitted, and the proton plus electron is neutron energy. So since we're already neutron, we're automatically subtracting the electron along it. Oh, okay. Which generates rotations. States are not necessarily invariant under rotation. Transform in a well-defined way. The three operators. Okay, XYZ. Rather intriguing structure. Angular momentum, bane of my existence. I mean, angular momentum isn't awful. Just angular momentum of quantum mechanics and nuclear physics is awful. Permutation of indices. This shows that we cannot determine all three components simultaneously in the quantum state. Only calculates the length of angular momentum vector and its projection on the z-axis. Okay. 7 forces resolved in the system is in fractional equilibrium. L is a non-negative integer. M is an integer satisfying absolute limit smaller than L. The projection is always smaller than the equal length for a statement in classical mechanics. Okay. Oh boy. It's like a simplified picture of a process of a fixed length angular momentum. Saying about the z-axis, keeping the projection fixed as shown in the figure. Constant is independent of the m quantum number, since the physics depends on the orientation of L in space. Is m the spin? What's the characters of quantum numbers? M is magnet. Okay, so it's gonna be spin. Alright. Spin mentioned. Yeah, spin, getting into spin. I wanna go back to the comfy non-spin chemistry without not dealing with spin. I don't want the past dealing with spin. Can we just... Is spin really necessary in chemistry? Can we like not? Can we... Can we just remove spin? How necessary is spin really? Alright, I'm just saying. What if we just like walk around it, you know? Find some alternative solution. Orbit was mentioned. Oh, it did, but this is quantum numbers. It's the same thing. Necessary. Quantum computing will be dead for 100%. Yeah, but like, how important is quantum computing? You know, do we really need quantum computing? Do we? And magnetism, I'm pretty certain. Do we really need magnetism? What really is it? Come on. Who needs quantum computers? We have normal computers. Isn't that good enough? No. Fine. Fine, have your spin. So, okay, the energy of a quantum state is independent of the m quantum number. Nice, thank you. The physics is independent of the orientation of the L space. Makes sense, unless we apply a magnetic field that breaks the symmetry. Of course, unless had to be there. We just find the multiples of 2L plus 1 states with the same energy, and value of L differing only in m. Wait a second, that actually ties in all nicely together, doesn't it? We just find multiples of 2L plus 1 states with the same energy, and value of L differing only in m. Okay. Magnetism is so necessary. Is it really? Come on. We don't need magnetism. We need magnetism. Like electrons, protons, and neutrons have spin. We can use magnetic field to separate to separate nucleids with spin up from those with spin down. Because of course we can. Spins are like orbital angular momentum in many aspects. We can write these operations to satisfy the simulation as well, but we find that this right here, the length of the spin is half with projection is this. Okay. I am glossing over this, of course. Of course I am. It's spin, and I make it. Of course I'm glossing over this. Shocker. Bit similar to you because learning chemistry right now. Because of enthusiasm. That's good. I like it. Generalizing. I feel like it's healthy to experience different fields every now and then. Quantum state L, S, J, and G, Z, it can be explained pictorially as in figure. Oh, that is actually really nice. I mean, I hate it because it's spin, but that is nice. That's a nice graphic. There, we show how for a fixed length J, the spin and orbital angular momentum about vector, which in terms of the it's easy to see that elements are fully aligned. We have. I would need. No, I don't have the background required for this. I would need to pick up a different book. Are you good in problem solving? I am fine at best. Anti-aligned, then okay. I don't want to pick up a separate book. I might have to. Half the people on the stream already left, and you know what? I don't blame them. I get it. I wish I could too. Spin. Quantum answers that this were very numbers walk. If the angular momentum quantum numbers couple LS, the length of the rest. Okay, right here I'm gonna copy this. Because right here we'll need a different textbook and we'll need to go back to it. A symmetry of the wave function, if we change mirrors loss of exam variance, we can do this operation twice and get back where we try any given value. This operation might be noted as pi is equal to, okay. Shown that for a particle with orbital angular momentum, the pi is made particles. Nope, I need a different textbook. Nuclear physics isospin. In contrast, the symmetries with exactly approximately symmetry for masses. Remember that dominant binding terms only depended on the number of nucleons, not on type of nucleons to deal with. Yes, I do remember that. I remember that much. It was just A. It was just A until the fact that something's a proton actually came to play. This is the assumption of another abstract quantity called isospin, which describes a new symmetry of nature. We assume that both neutrons and protons are manifestations of one single particle, the nucleon, with isospin down or up. Respectively, we shall have to see whether this makes sense by looking at more detailed nuclear physics, protein amplification. What? That's cool. In a time when the stream can go in the background for me. Yeah, I get it. I would put it in the background too if I could. Apart from a neutron-proton mass difference, the isospin symmetry in nuclei is thinly broken by Coulomb force, which acts on protons but not on neutrons. We shall argue that the nuclear force that couples on the nuclear charge rather than the electric charge is the symmetry of the nuclei. We can study both a nucleus and is a mirror image and the exchange of protons and neutrons. One example are the nuclei. 5 neutrons, 5 protons, 2 neutrons. Okay, so, okay, I mirrored, I see. Ah! What about these two lines? No, wait. Oh, yeah, what about these two lines? And this one? Because it would just be a matter of spin. Unless you can combine them differently in novel. Okay. No, I don't want to deal with this. Well, I will have to deal with this. is that I should really just learn more about spin before going into nuclear physics spin. I will have to get back into this. I love it. I'm fine. I'm pretty toxic though. Thank you all for the kind words, but long story, and I'm not nearly drunk enough to explain it. Scattering of nucleons. Okay, the attraction of nuclei together. First of all, this is from old experiments of particles and nuclei. One can learn that the range of these forces, femtometers, okay. Nuclei saturate and are bound would then naively build a picture of potential strong process of short distances, show some mild attraction and range one just so as sketched. Okay, so like this. Coulomb force can be derived from a potential need for the size of R. As well, the simplest way to construct the rotationally invariant energy for particles with spin, what was going to rise? Well, since we have taken force to connect pairs of particles, we can just study the actual two nucleons by looking at both bound states. There's only one. You know what? I feel like that might be it for today's live stream. I'm tired. I'm going to go walk on the video. Yeah, I'm not gonna rest. No, that would be too easy. I'm gonna go walk on the video. Not for me, for someone else. Then I'm going to walk not on the video, only for money. And then I'm going to walk on a video for me this time, for this channel. And at the same time, I'll try researching more about spin, and then I'll get back to this textbook. So, I suppose for now, that'll be it. Thank you everyone so much for watching. Thank you all for the kind words. Thank you Ashad for helping. Thank you everyone so much. And for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.